All right, let's go ahead and take a look at page 2 of our review for quarter 3. So question 6 says, what is a Fibonacci sequence? And list the first 10 terms of the series. Okay, so when we have a Fibonacci sequence, remember we took a number and then the next number and we added those together, and those two become your next number, right? And then you add these two together, and then that becomes your next number. So let's show what that looks like. So I start with 1. I have nothing to add with 1, so the next sum would be 1. So 1 and 1. 1 plus 1 gives me 2. 1 plus 2 gives me 3. 2 plus 3 gives me 5. 3 plus 5 gives me 8. 5 plus 8 gives me 13. 8 plus 13 gives me 21. 13 plus 21 gives me 34. 21 plus 34 gives me 55. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, we got the first 10 terms in the series. So that pattern is just adding the previous 2 terms, and then you get the next term. Use the graph to the left to answer the following questions. What is the degree of each vertex? Remember that our degree is how many edges are coming out of that vertex. Okay, so let's take a look at A. A has 1, 2, so it's going to be a degree of 2. B has 1, 2, 3, that's 3. C has 1. D has 1, 2, 3. E has 1, 2. And F has 1. Okay, super easy there. So I'm going to erase those little marks that I made. Name the vertices that are adjacent to B. So if I take a look at B, I have D that's adjacent. I have E that's adjacent. And I have A that's adjacent. Erase those. Which vertices are odd? Well, B is odd, C is odd, D is odd, and F is odd. When we talk about odd, we're talking about the degree. And then which vertices are even? A and E are even. All right, for the 3 graphs below, state whether they're Euler Path, Euler circuit, or neither. If a path is a circuit, write down the full path circuit using the vertices, separated by commas using your pencil arrows to show the direction of the path or circuit. All right, so remember with Euler's, right? We want to know the degrees, because if we have exactly 2 odd, it's going to equal a path. And if we have all even, it's going to be a circuit. And remember, with a path, if we build that path, it has to start and end at an odd. And with our even circuit, we can start anywhere. Start anywhere. Okay, so let's go ahead and take a look at the powers. So I'm just going to go ahead and write them here. 2, 2, 3, 2, 1. All right, so I have exactly 2 odds. So I have a path here. And I have to start at one of the odds and then end at an odd. So I'm going to pull this one. Let me make this a little thicker. Okay, so I'm going to go there to here, to here, to here, and then back to there. Okay, so I ended at that 3. So let's go ahead and see what that looks like. It's 4, 3, 0, 2, 1, 0. So that's my path. All right, let's take a look at the next one. Let's do our degrees. I have 3 there, I have 2 there, I have 3 there, I have 3 there, and 1 there. Nope, I have nothing because I have 1, 2, 3, 4 odd numbers. That doesn't satisfy either condition. All right, let's look at this one. I have 2, 2, 4, 2, 2. I have an Euler path or Euler circuit, excuse me. That's an Euler circuit. And then I'm going to go ahead and draw my path. I can start anywhere. I'll start at A and then go to B and then go to E, D, come back to C and up to A. I don't want to say it doesn't matter, but there's several ways to do this. You could start at any one of those. I just happen to start at A. You could start anywhere. So A to B to C to E to D to C to A. The key to an Euler path is that it starts and ends at the same spot. All right, given the graph below, determine the total weight of the path. All right, let's go ahead and draw that path, and then we can easily build up all of our additions here. So A to F, so that goes from here to here. F to G, G to H, H to I to J, J to E, E to D, D to C, C to B, and B to A. Okay, so that's going to be my path there. So my weighted walk here. So I have A is 2 plus 1 plus 1 plus 1 plus 1 plus 2 plus 4 plus 4 plus 4 plus 4. All right, so by the time you add that all up together, you should get 24. Double check my math on that. So 24. And then is this a Hamilton path or circuit? Okay, so with a Hamilton path, the only difference between a path and a circuit is that you don't start and end at the same space. So a circuit starts, ends the same spot, and Hamilton path just hits all vertices, but doesn't land on the same spot. Well, if I take a look at what I've done, and the Hamilton, remember, Euler is all about edges. So Euler starts with an E, and it's all about edges, which starts with an E. So keep those two as a pair. Hamilton is only concerned about the vertices. So I have no connection to that to give you something to remember. Just remember it's the one that's not the edges. So every vertex has to be chosen. So you cannot hit a vertex more than once, whereas with Euler, it doesn't matter. We just need to make sure all the edges get hit once. So if I go 1, 2, 3, 4, 5, I'm hitting all those interior, and now I'm starting to hit my exterior. Okay, and I end up back where I started from. So that is actually a Hamilton circuit. Okay, and let's go ahead and write Y. All vertices touched, right? We pass through each one, and then starts, ends at same spot. Okay, so that is page 2 of our review.